Yes. So good evening once again, and thank you all once again for joining the class. I'm still the tutor for tonight, and my name still remains Yemi Ayola. So it's still continuation of introduction to software testing, mainly the background, manual testing, all this. But today, we'll go slightly different. So we are going to be, our learning objective for today is more on SDLC, Software Development Lifecycle. So that's what we'll be taking today, Software Development Lifecycle, the different types of modules, the pros and cons, the concept in understanding testing. So that's what the intention is for tonight. And maybe furthermore, we'll move into SDLC, that's Software Testing Lifecycle. So not to waste more of a time, we'll go further. So the software development life cycle, the acronym is SDLC. So we are talking about software development life cycle. So is an iterative and incremental development model. So we have various types that is like a model. So we have various models, various ones that we use. But these few, just mentioning some of them, relational unified process, we've got Spiral, we've got video model, we've got Scrum. What you are doing now falls within this remit. Scrum Agile, Kanban is more of a traditional one, but falls within this kind too. Then we've got the sequential type. It's still software development lifecycle. So the first one was incremental. Then the next one is this is sequential, waterfall and V model. So note here that this first one, we've got 5. They are they are the various ones, but I just broke it down into 2 so that you know the category 1 belong to what the other belong. These ones are iterative. Incremental, it increases. You will understand further when I start explaining. So the next one is waterfall and V model. So let's go into it. So software development life cycle model. So we have the 3 major ones that we do, that we use. The 3 major ones is waterfall, which is linear model, V model, which is sequential developmental model, and we've got the iterative incremental development models, which is agile. If you look at the first screen that I said iterative incremental, this is where, and you saw Scrum there, this is where it falls. The other one that is sequential, both of them are categorized under this. But to be honest with you, ignore those ones that I've shown you. These are the 3 major ones that most of the time they will ask you, have you worked in that environment? And I'll tell you that you have worked in them. So what is software development lifecycle? SDLC, as we call it, or software development lifecycle, is a process that produces software with high quality and lowest cost in the short time. That's the essence of agile. We want to do things quickly, but we want to ensure that it's thoroughly done, it's tested properly. We do it little by little, but we are moving very quick. Software development lifecycle provides a well-structured flow of phases that help an organization to quickly produce high-quality software, which is well tested and ready for production use. So accept it that when we are saying agile, the reason that agile came into practice, you will understand while when we go along. It's easier. You can be testing functionality little by little, get it released, everybody sign off. We don't need to wait till the end when things are bad before we now start bringing people in. So I always like to use this kind of phrase to make you understand. So let's take a life cycle of chicken, even human beings, but I'll use chicken at this phase. So what's the life cycle? This is where this person starts. It starts on an egg. So mainly we want to define the life cycle, how a chicken grows to get here. First is the egg. Inside this egg, once it starts in the embryo is just like a baby forming there, is starting forming. Then later on, after few days of this thing, it will arch. So this is the arching period. That chick is trying to come up, so it will break the egg. Then it will now turn to a small chick. By the time it's eating, and this thing, it will now turn to an adult, then it will turn to a chicken. So this is life cycle of a chicken. Take an example of you and I. How did we come to an existence? In the womb, you are there like this. This is how we are, bagged in the water. With the when it was started, two people came together. Then you have this in the baby in the water is forming, is growing. After 9 months, the baby is given birth to. From there, because he is come out, then that is his prime age, his young age. Then by that time, you see, from 18 is turning to an adult. And that's the way you and I we are today. We are 40, we are 50, the others are 60. So we are all there and we are growing, keep growing. So that's the way the life cycle of chicken, life cycles of human being are. So the same process, bring it into the IT world. We also want to teach that life cycle, how things go in this circle and make it a whole project. From this little chick, this little egg, where we didn't know anything about the project, and then it will now form a big project like this. Like all the bank apps that we use, it never started before. Nobody used bank app. Everyone will sign a check. You go to the bank, you write a check, you be on the queue. The queue will be so long, you cash money. So those process now started getting automated. We have the app. You don't need to go anywhere. You can transfer millions on your where you are seated. So all those process. But it started little with the check. From the check, we looked, how can we bring it in? Okay, let's take the check to cards. So they did it now. So all your money now will be on the card. You don't need to, you can just go there. Now, how will they be able to utilize a card? They brought the ATM, you insert it in, you get your money from there. From there, you got it. Okay. Now we don't need a physical card again. We can use a virtual card. All those things are what started little from paper. Now we have it in the app. You don't need to go anywhere. So that cycle is what we want to practice now. So SDLC, as I said, the acronym, Software Development Life Cycle. It is also called Software Development Process. SDLC is a framework defining tasks performed at each step in the software development process. Have it in mind, is a framework. It's something that you want to follow each step and ensure that we have it done at each step and we get a better result. If, for instance, at the beginning of, if an example, at the beginning here, where we've got the egg, once you break the egg, it will never form this again. So which means we didn't end up getting a life cycle. We have cut down that life. So, but having said that, this just know in your mind that is a framework. We want to follow this process. Software development life cycle. Software development refers to a methodology which clearly defined processes for creating high quality software. In details, the software development lifecycle methodology focuses on the following phases of software development lifecycle. One, requirement analysis. This is done by the product owner, the business analyst, gathering requirement, coming in. We've got the planning phase. We've got the software design, such as architectural design phase. So when the requirement is being gathered, then someone will start visualizing it. How do you want it? It started from an egg. So the next thing we want to visualize is that this is the requirement, which is the egg side of it. So we are now planning, how do we want to make this egg turn to a chicken? Then now that the planning bit come in to say, okay, let's start first on a light on it. Let's start looking for a way to make it hatch. So let's protect it. All those planning phase. Now, someone as we are planning, as they're planning, the other team will be looking at it in a bigger picture. How can we design this? How is this going to look like? We have laid the foundation of the. What exactly do we want to build on this foundation? Is it a 4-bedroom house? Is it a 10-bedroom house? How sufficient is that? Those phases, those diagram is what the design team will be looking at. Now, the software development. Now, we also will be thinking, okay, how are we thinking about implementing this? Now, it now come to you and I. How are we going to test this? So we need to start from this little one. If the egg, we need to be mindful that egg must not break. Once it breaks, it stops that. So all those process, those phases, what is going to happen is what software development life cycle preaches about. So you talk about the requirement analysis, the planning phase. We talk about the software design and architectural design phase, the software development phase, testing phase, and finally, we talk about the deployment. We have finished, and the the chicken is now from the egg to the embryo, from the embryo to it hatching to it being a chick. Now is an adult. We are ready for Christmas. Then you bring it out, you deploy it out, people can start buying, then they can eat for Christmas. That's the life cycle. Oh, or you want to rear it, you want to keep laying eggs. Fantastic. So that's the whole thing is talking about. Now, I just make this, I look at this diagram kind of it. So number one, you see that requirement analysis. From requirement analysis, it goes to the design phase, design to development, development to testing, testing to maintenance. That is the structure. So you go from one to the other, 2, 3, 4, 5. So let's start with requirements gathering and analysis. Understand the proposal put forth by the customer. This is key. Reason is that if a customer give you information about their needs, my advice is always, maybe as a business analyst, as a product owner, as whosoever is getting the information, even you as a tester, if you don't have a BA in the organization, once you are given a requirement, you've discussed with the business, you've discussed with the client or the customer, put it back into writing and let them know. You said you needed X, Y, Z. We want this to work as expected. Is this what you want? When you put it in an email and you copy the right set of people, you've asked your question, they iterate back to say, I agree with it. Ah, no, you left this point. B, you have added this point. Simple. But it gives you a visibility that you have it backed up somewhere. The same thing I will do when I'm testing, you will do the same process, which we'll come to. Understand the proposal put forth by the customer and then gather their requirements for a suitable solution. Be sure to probe as much as possible to gather as much information as you can at this stage. So, what I always advise also is that when you're going for a requirement gathering session, people know what they want, but you also should be prepared to ask, is this, is this that? You can't pose your opinion to them. They know what, they are the owner of the product, but you can tell them that, oh, have you looked at it this way? Do you think this is going to work this way? Okay, what is your thought? Then they bring those in for you to have. Ask many questions as possible. Whatever you feel is kind of ambiguous in the use of word, or they make it so ambiguous, try to break it down. Get more explanation on it. It's easier at this phase. Look, if anything fails at this requirement gathering analysis, believe you me, it's going to affect the whole project downline. So you want to be sure that you've got the real stage. This phase is heavily documented so that developers can revisit requirements at any time. So we'll say if the BA gathers the requirement, it must be documented. When I'm testing, my yardstick is that you give me a BRD, you give me a data mapping document, you give me the architectural diagram. If there's one solution, I have those 3 documents with me. Reason is that I refer back to each of them. They must be in sync. If one is out of sync and the other is, I query whatever is there. And I'll tell you, as I'm querying it, I'm writing it out to say, in this, in the solution architect document, the data flow, number this is wrong for the user story. Number this is wrong for the requirement gathering. So the data mapping spec has XYZ. I will send an email. I don't need it. You reply me, you don't reply me. As long as I've sent it, you must come back with me with feedback until I finish the testing. If you don't, all those emails, I always save them. I add them as part of my test completion report to say, this user story I've explained and I asked for clarification. This is the email to it. You have it there. So I'm also trying to cover my back to say, I've done my own due diligence. You also should look at it. So you don't come back to tell me that what you have done is wrong. So if anything goes wrong here, it affects every one of us. I will test wrongly. The developer will develop wrongly. The solution architect will design wrongly. So that's why this stage, this level is key and critical. Like every other stages in this, every other phases in this place. So and we can revisit at any time. So the next thing is planning and design. What is planning and design? This is when you elaborate on a project plan for meeting those requirements laid out by the customers. Once you have a plan, design concrete specification for the developers to utilize, like screen layouts and other materials. During this phase, you need to analyze the problem in the context of the organization policies and objectives. So it's just laying out the way a plan and design phase is meant to be. So you want to ensure that, and like I said now that this is the expectation of the once the design phase is coming up, they are planning, you ensure relevant screenshots, whatever you have, give it to us. That is that is what developers will build on. That is what testers will test on. That is what every one of us are going to look at as a phase. So it should be reviewed at every point in time. So building. So how do you do it? During this phase, the actual code, building is more of development, is constructed. This is where the developers stand. This is done by a single developer. It depends on the project, a larger team, or even several teams, depending on the scope of work. So it depends on the kind of project you're working at. Developers will need to track changes to the code. So you are going to learn that too in this phase. So you'll be able to see most of the things when they're coding. And if there are any different team working together, that they are able to know what the others are doing, changes can be documented either formally or informally. This is just on the development phase. It's for you to be able to build what this development work, the code according to what they have in the um, requirement gathering session, in the solution, in the planning and design phase. Now they build towards it. Then the next phase is we're now talking about testing. What exactly are we going to test? What are we looking at? Then it takes us to know that now we have the code by the developers. It's been deployed into the test environment. It's time to test now. So usually this is done in special environment. I explained to you in the last class that there are environments. You'll be given the URL. You've been given the environment. It will inscribe maybe in dev, seeds, UAT, all those kind of inscription will be in the endpoint. So the team can check for bugs and other mistakes without being distracted by too many variables. So those test environment is confined, is within ourselves, is just within us. We are the ones seeing things and doing it. So hence we have dedicated environments to test on. So fine. This is the development phase, deployment phase. What happened in this deployment phase? After we have done, found out the errors is being fixed, we are now okay. We've rubber stamped it that from testing phase is fine. Then the what we have deployed is what we have tested in that environment and everything fixed and we can attest to it can now move and be deployed to the next environment, or if we finished, then it can be made public for people to go. So it's just a way. So but to be honest with you, you don't just test in seats and throw in production. So just chipping this in, the way testing is done is that there are various environments. The dev environment is the main place. All the old work, the chunk, the modules, the way they develop is there. It's more of a dungeon where all the things are coded and there, stored there. So you take a portion of what you want to develop, you create a branch. So a branch is like you've got a big tree, a big one. So that tree has everything that you need. Now, for that tree, for others to be able to work perfectly, we need to create a branch. So take one branch. So that branch you're creating might be a branch that you're using for your project. So that branch will be where you'll be merging all the codes. So that branch, you have taken what you need from that big tree and you have moved it to this code. Because codes are like things given, they are bought and developers work on them, but they work on them in bits and pieces because you might have login code is different, sign in code is different, search code is different, adding to cart code is different. But when they finish and they finish coding and is there in their local machine, what they now do is that they integrate it together. So what is integration? You start for, you have coded for login. So login is the first thing you want to do. So when you code for login, you put it, that will be your first phase to be executed. The next thing that should follow, it will open the page and land you there. The next thing that should follow is how to navigate around it. So all the things that you can navigate, all the channels, it will follow up. What is going to happen at the end? So in those sequence, there are events, they need to happen at every phase. They now bring it and they put it in the branch, integrate it, unit test it there. Once they are happy that things they've finished their work, then they take it to another phase, which is the test environment. Test environment are in various phases. So test environment will be that is now more confined than where you are coming from before. So before you were in the dev environment, the code was there. Code might work perfectly in the dev environment because it's their environment. A lot of things have happened. They can tweak, they can do everything. Now, but when they deploy to sit environment, you start finding bugs, things like that. That's the reason you and I were working. So after a dedicated test environment, in some organization, we have various types of test environment. I can't tell you, I've worked like me. In fact, when I push one poly, I start looking for all my environments. But because I know what is expected to be linked to this, to link to that, straight on, I come to you and tell you XYZ. I raise my concern quickly to say, I'm not seeing this guy flowing through the channel that I'm expecting him to. Oh, yeah, you're right, Yemi. Okay, let's rewire or repoint to the environment you want. Where do you want? I have my environment list, what I work with. So I give it to them. Most of the time, they ask you questions that. So those are the ways you work. So now when you finish test environment is managed by testers. Is your own place. You guide it jealously, you talk, you test there properly. Now, after test environment, the same code that have been tested, you have found bugs, you have found bugs. Don't forget what I told you about the general principles of testing. If you remember when I said pesticide paradox, it doesn't mean that because you have tested in the seat environment, that when they take it to UAT, they won't see any bug. It's a lie. There's every possibility the bugs are there. And I will explain the reason why we are moving from environment to environment. I'm only taking my time to explain this to you so that you have an understanding of it. After we are moved it from test environment to UAT environment, what is UAT? User acceptance test environment. So when you move that code there, the same code that you have tested in seat is what they deploy again into UAT. Because now what has happened is that code that has been deployed that you've tested in seats is now getting purified a little. We want to make sure that the water is clean before we bring it out. So the first stage is that we took it from the the dirty water that we started first. We've purified it. They've created a branch. Now they have put it in seats. So seats too have sieved the water, checked that the water is clean, did all the tests, bring out the bug. So the same water is still the same water we are carrying from the same bucket. We have now put it in UAT. So UAT now will now try hard. Let me find one thing so that I can make this water too clean. After UAT environment are finished, we have another phase, which is pre-production. We call it pre-production. This is a mirror of production. So when I mean mirror, when you take a mirror and you look at yourself, is what you are seeing in the mirror, that is who you are. That is your appearance. If you are dark, if you put a mirror, it will never show that you are light, except if you filter it. Man, it won't show. The real mirror will show who you are. So that's why I said is the mirror of production. So that's the mirror of production. So when the next phase after UAT, it goes into the pre-prod. So when it gets into pre-prod, we now test heavily there. So once you attest to say we have finished pre-prod, we take it to production. So what happened in production? Production, we will get there. These are business users. They will test it. Once they test, they come back. If there is any issue, we start from the root. But most of the time, we catch all the bug in pre-prod. We don't know how it's going to work when it's integrated in life, but with pre-production, I can tell you if it works fine, the connectivity is what we might just cause an issue in production. So most of the time, if it works fine, it goes into production and they test there. Then now there's this phase that you now want to go live. When I mean live, it's visible to the public. That's in production phase. So when they finish testing, then they make the host. They change the host and make the host live and is in the cloud. That is how all the phases of environment are. Please, as a tester, don't make any mistake of jumping from one environment to the other. I will give you an example. Myself, November, I was testing on a project and I emphasized, I've tested in seats, but the business was so in a hurry. Oh, because it's December, once you're going on holiday now, you won't have this thing. And we were all in, it was a big meeting. And I was asked that you have tested it in seats and you're fine. I said, yes, I did. I tested it and I'm sure it's working. So now we want to push it to production. And I told them, unfortunately, I will not be able to sign off to production. And they said, why? I said, the reason is that we've not gotten all environment in sync. I can tell you predominantly that he's going to fail in production. Oh, no, 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 don't say that, hear me. Is you have to, we just want to eat quickly. I understand. I said the environment are not in sync. So I'm not too happy for us to push into you. So, but it's not my call this time around. I've backed out. But I gave them my test completion report to say I did not finish testing. I only stopped at six and I gave it to them. So um, the customer said, if there's anything, I take the blame. Hear me. And I said, fantastic. And I sent an email to say, this is my test completion report. It's not complete. But I know before you can get an approval to go to production, they need me to sign off. I'm only going to sign off on seats that I've tested. And they said, fine. So I signed off and they took it to production. I know, I told him, he said, how do I know he's going to fail? I said, I'm 99% sure he's going to fail. So, and he said, yeah, me, I've been doing this, it will not fail. I said, okay, that's fine. So I agree. I said, because you are the owner and you know you are more expert than me. So I left it. I think we do it mainly weekend. So after the deployment, when I got there Monday morning, I just saw everyone, oh, policies are not flowing through. You know what? Nobody could come to me. Nobody could come to me. So the only thing they just said, oh, emergency meeting. So yeah, me, now we understand that the environment, I said, fantastic. So don't worry, we won't do it again. We will put it because we have code freeze. We'll do it in January. And I said, that's fine. So let's follow the route. I'm going to start all over again from seat. You move it to UAT. Yet we follow your lead. And that's how we did it. And we are now in February, we are now in production. Everyone is happy. And that is the way it is. You don't need to jump. If we didn't jump that environment, the deployment phase, we would have caught whatever will happen in UAT. If we didn't catch it, we catch it in pre-prod. We will know there's going to be an issue. Instead of jumping from a lower environment to production is very risky. So that's what I want you to understand. So I won't talk about environment again. I've given you the basic, the high level of it. So maintenance. During the maintenance phase, the software is maintained so that it stays effective and relevant. So once it's in public, Everyone is using it. But it doesn't mean that you should have a maintenance phase. People will be having issues. Oh, my card is getting, I don't have, I can't access my card. My PIN is out, my this. So you need people to be looking at the application. It's not that because you have, then you sign them off. No, you also need to tweaks can be made to initial software so that it remains viable solution that is free of bugs. So maintenance will always continue to come. So the next phase you are going to is the waterfall model. So now each of the framework, I've talked about the life cycle, what it entails. I've explained it in details. So now we want to now start each of the model, waterfall. And you would ask me, why did they say waterfall? Look at this diagram. So this is the diagram. In this diagram, you see waterfall. It's always like a waterfall. You see, requirement phase, the design phase is falling like water. And I will explain this concept to you. So this means that it's a linear concept. Linear is going straight down. This means that for each phase must be completed before the next phase. So let's give an example. You are working on a project. The project you're working on currently, the Blue Sky project. The first thing is they gather all the requirements. Without nobody knows what the requirement is at. Only the BA, the product owner, they gather the requirement, get all the information. If they don't finish, design cannot start. So it's after they have gathered the requirement with the whole business, then they come here, they do the design phase. After design, they come back here. Once design too will finish his own job. Then it will take it to development. Development will take time to code very well. After development finish, we as testers, we will take our time. We will test it religiously just to ensure that we have the face. We'll test it religiously to ensure we have those phases completed. So when we test it, then from there it goes to develop the to deployment. Deployment. Then after deployment, then it goes maintenance. So this is what the waterfall model is. Now you ask me, oh, it's a good one. Yes. So I'll come back to the reason. So let's take it step by step. So I've explained to you how the process works. This means that for each phase must be completed before the next phase can begin. So if you don't finish requirement, we can't start design. If you don't finish design, development cannot start. If you don't finish development, testing cannot. Like that. Please, phases do not overlap. For each phase, goals are defined. They must be achieved and signed off. Correct. Requirements phase. Users and business required are defined. Design phase. System design, architectural designs are defined. Development phase. Code is implemented in small program units and tested. Testing phase. Test plan, test scripts, those things I mentioned last week. System is tested end to end, and end-to-end users testing is done. Deployment phase, product is released into customer and users environment. Maintenance phase, to resolve customers' environment issues. That's it. So these are all the levels. Now, let me give you an example. So let's take an example of a phone. Let's take the latest phones that we have now. You know, the latest phones that we have. Apple product. Let's take an iPhone as an example. Just use it. So now, if we want iPhone 16 to come out before this thing, maybe when iPhone 13 Pro Max was out, then I'm not a phone. I don't use phones that mine is just that my phone that can receive call and do that. So I'm not used to, I don't know brand. So Pardon me with that. So I might just say, I'm just saying what I know about it. So let's say iPhone 13 Pro Max is what is coming out. And you were given that iPhone 13. I don't know the year it came out, maybe 3, 4 years ago. So you were given to test. We want to, that's our case study. So we are given requirement for iPhone 13 because we have 12 before, so 13 for 13 to come out. So they need to gather the requirements. Maybe business analyst will say to gather requirements, it will take us and we have just 6 months, 6 months to deliver this. So then the business analyst will say, oh, it's 3 months. We can use 2 months to gather requirements. Don't forget that they will use 2 months to gather requirements. So if they use 2 months to gather the requirement due to customers' availability, due to what they can do, so they use 2 months. Within that 2 months, all of us can't do anything because we have to wait for them to gather the requirement. So when he finishes gathering the requirement after 2 months, the design phase will come. Oh, for us to draw this architectural this thing, it's going to take us roughly like a month and a half. So, after 2 months, the design phase will come. You give it to them, take another 1.5 months. So that's 3.5 months. After the design finish, now development phase. In development phase, there's no how we'll take 2 months to do that. So if we are going to use 2 months to develop that, that's very good. So add 2 months to the 5 months, 5.5 months. We have 7.5 months already. I mean, to the 3.5 months, we have 5.5 months already. Don't forget, our deadline is 6 months. Now, when development finished, it's testing phase. We need to test it vigorously. We need to go through various life cycles. We also will take 1.5 months, 2 months. Add it to the 5.5 months. So that's already 7.5 months. Then the deployment might take another 1 month. So added there is like 8 months. So now when they deploy into this environment, you know the irony? By the time they come here, when we are testing, if anything has happened and is not working as expected, we'll have to deploy. Then when we go, we'll now come back, we'll start from the beginning again. Don't forget, the whole 6 months, I only reduced it. Requirement gathering take a long time, more than that. So the whole of that will not come back because testing failed here. They've not fixed all the bugs because they won't be fixing the bug. They'll wait for us to finish testing. We'll deploy here, then we'll now go back, start all over, deployment phase, and that's the way it is. So it's long. You might not, in fact, iPhone 16 would have been prepping to come out before iPhone 13. So it would have, all the customers that booked for the 13 would have gone way ahead of that. You, as a business, you won't have do this thing. So what are the pros, advantages, and disadvantages? Phases are processed and completed one at a time. Works well for smaller project. So smaller project that it's just a website you want to create. We know everything about the website already. We have the whole information. This process can work religiously. Where requirements are very understood, well understood, it will work perfectly. But the disadvantage is that complete a stage before moving to the next. If something is wrong in a later stage, there is no chance of going back. You can't. You can't go back. You can't even look back. This is an expensive model. And don't forget, we have already started coming from here. Look at the whole 7 months, 8 months that we have been sitting before we got this. It's wasted time, wasted resources. I won't be able to do any design because I don't have requirements. How do I want to design my test script? I don't even know the project they are bringing up. So that's why we say it's expensive. So V model. So the reason for it's still a continuation of the model is look at it. The reason for this face is you can see the shape is a V shape. So why this a V shape is that for every face here, every verification phase, there is a validation phase. So what do I mean? When you are doing user requirement, you validate acceptance testing against it. So when you do the user requirement, you start testing against it. You start testing it. So at this verification stage, there's a validation. So you are verifying, you are validating it, checking whether it's correct. Also, the this other phase, software application phase, there's a system testing. So system test plan phase, it will use to validate it. So at this verification, so each of them is validated until you now code, until this code is being designed, then until when we start testing fully. So this is verification, validation. Please take these two words again. In interviews, my questions for me to know people that I want to take that understands testing. Those two words that I always ask you, most of the time people mix it up at all. So verification phase, validation phase. What is every verification? You are verifying something. This is the product you have been given. You are looking. This is the product that they have given you. You are verifying that this is the product that you have been given to test. This is the phone you have been given to test. Validation is that phone working as expected as what the customer has asked you? That is what it means that you are validating. I am checking whether this thing is working as expected. That is what validation is. Verification is that this is what we have been told to produce. This is the product. This is the face that we are. But who is going to counter it? Who is going to check it? Validation man will come and check what this verification guy is doing. So, what are the phases? Business user requirement. So here, a detailed requirement of the detailed requirement of the software system to be developed are gathered from clients. So when you gather that, the validation guy will come in, the testing phase. So acceptance testing will be done at that phase. So it involves testing the product in user environment. So that's that's how you validate it. You are going to test it in that user. Software application design. How will the system work and interact? Functionalities and features that goes into the system. So you do system testing. Checks the entire system functionality and the communication of the system under development with external systems. Architectural and high-level design of the software. That's the third phase. So now high-level technical detail of the project. You have it. You have coexistence of components that make up the system. So then we have integration testing to that phase. These are test levels. To be honest with you, they are test levels. And these test levels are the validation phase. It's part of SDLC. It's part of the things I'm still going to talk today. So integration tests are performed to test the coexistence and communication of the internal models when the system within the system. So the last phase is the model and detail design. Once your system is ready to use, you may later um, change the code as per customer request. So any updates, any new thing, you can now change. So unit testing is the face that we use in this, and test individual models and components. So as I've told you, is one code is for login, is a different code that is for search functionality, is a different code that is to add to cart, is a different code to navigate. They are in small bits. You can't model up the code. It won't work. There will be a lot of errors. You will give yourself headache. So that's why they do it in bits and pieces. So the coding phase 2 is there. So we follow the standard rule of coding. So this is it. So this is sequential. This means that every single phase in the development cycle, there is directly associated testing phase that is planned in parallel. That's it. So now, what is verification? Are you building the right product? That is what this guy will be asking. Verification. What are you doing? Are you building the right? But validation will tell you, are you building the right product? It will ask you to. And it will also say that, does it meet the user's need? Now you ask me, how will I know it meets the user's need? It's the requirement that's been gathered. It's been said in the requirement, the login should have a username and a password. Username can either be email address or a phone number. It has specified it there. Then you know, can the user log in? Can he register? Those are the things that this validation guy will be fighting against. Then what are the pros? Testing early in the life cycle is a pro. It's very good. You test early every phase, thereby enhancing the probability of building an error-free and good quality product. That's it. It's very good. But the major drawback for vModel, on vModel, if any change happen in the middle of the way, then the test documents along with requirement documents must be updated. So if it was on the third phase, if it was this phase that we had an issue, you'll have to go back and start all over again. Update it. You do acceptance testing to counter it. You go back here, you do this. So in a nutshell, you've wasted time. You are here, you found out that there's a bug here, you now go back. So it's a drawback, a major drawback. So narrative incremental development model, to be honest, is agile. Agility. When you're agile, strong, ready to do everything in bits and quickly. Agility. Agile. Iterative. Incremental iterative. Requirements are broken down into multiple standalone models of software development. Like standalone. So log in, stay on your own. Today is you we are working on. Everybody will work on login. So developer will build, requirements will gather on login only, we'll speak to customer. We know it's only login we are doing this phase. And once we finish login, we test it proper, we are happy, we keep the code. We keep it, it's already deployed, is in the customer environment. We have checked everything. Everybody's happy, sign off. The next phase we want to pick is the search functionality. Fantastic. So this time around, we are all working on search functionality. Requirement gathered by BA, by product owner. The next thing, we go into development phase. Development, fine. Design, fine. Testing, very good. We are happy. Deployment, good. Customer, client, are you happy? Bug free? Yes. Happy in their environment. So it starts with this increment. So you see is 1. So you start first with the first one. I said login. When you start with login, after you have built login, you're happy with it, then that is when you think of adding another one. What else can we do next after login? It's search functionality. So now we go back. We'll say, okay, we are going to add 1 to login. So now this is login. We have added set functionality. Okay, now, yes, I'm happy. We're happy with set. What else can we add? Then we come back now and think, oh, we can add something else. So you add, and that's the way you keep increasing and incremental until you get to the end of the project. Each iteration passes through these phases. Look at what you do: the requirement, you do the design, you do the coding, you do the testing, software product increment. So that's the way it does. So test, you do requirement, design for login, we do the coding, we do the testing. We are free. Everybody is happy, customer is happy, we are happy. We'll pick up the next thing. And each subsequent release of the system adds function to the previous release until all design functionalities are being implemented. Iteration output, partially delivered products. The process is repeated until the entire product development is completed. The repetition of this process are called iteration. So because we are doing this. So when we took the login functionality, we did requirements, we did the design, we did the login, we did the testing, we deployed it. So that's one phase that we have done. One iteration, one increment, one. So that's the first iteration. Now we want to take set functionality. We'll do the requirements, the design, the coding, the testing. The next thing is the second iteration. So we've added more things. So that's the way the iteration is until you get to the n number of iterations. It depends on how many sprints you have. For every completed iteration, a product increment is delivered. When is it used? There is a need to get a basic functionality delivered faster. That's when you use this mode. So if you know that your client needs this within 3 months, within X number of months, it's wise to start it. So what are the pros? Quick delivery to the market. Customers can provide feedback to each product increment, thus avoiding surprises at the end of development. Requirement changes can be easily accommodated, so at any time. So what it gives is that when you deliver login and it gets to the customer and they've given feedback, oh, in the login, okay, previously we said we wanted username and phone number. Okay, we don't want phone number this time. Let it just be username. Let it just be email. That's suffice. We want only email. We can accommodate any changes in Agile. Changes are not pegged. It can be accommodated. So, the disadvantage requires effective planning of iterations. So you need to know what the needs are. So all these questions are the things that you would have asked the clients. So Agile, that's what I've said. So just an iterative part of it, just to iterate again on what I've said in the previous slide, is that I'm not showing physical to you to know how the incremental phase take place. Requirements, you see, you gather requirement, you analyze it, you design it, you code it, the software product increment. So that's iteration 1. So we finished iteration 1. Now let's go to iteration 2. Requirement, we analyze, we design, we code, increment 2. That's iteration 2. We do again requirement, analysis, design, coding. We have another increment, maybe 3. We do it until we get to the end increment, which is the final one, and is that will be our final sprint. So this is just an overview of it. So that's the way it is. So that takes us to how this framework, how this model works. So you have seen the way I did all those increments. So this is, we now moving into the phase. So definition of ready. What is definition of ready? Now we want to start a project. You want to look, let's take the phase, let's take along the login functionality that we have looked at. We'll have to look at it. Are we ready? Do we have the requirements have been gathered? Everybody have attested to it. Planning phase has started, and we do that. So that's when everybody is in line. We understand what we are going to do. We can test. We have everything that is needed. That is when you can say you are ready. The developer understand what their remit is. The BA also have done his or our own job. The architect have done. We as testers too, we are fully ready. We have done our script. We understand the requirement. We are happy with it, ready to kickstart. Those are that phase. That's when you say you are ready. That's your definition of ready. So when we have everything here, when we are ready to move, we take it to the backlog. There's a backlog, a big bucket where that is dumped. So we pick it from here, we put it in this backlog here. So from the backlog, we pick what we want to do for that sprint. So in this backlog, let's say in the backlog, there's login functionality, there's set functionality, adding to cart, submitting, payment, all these kind of things are in the backlog. But this time around, for this sprint, this particular sprint, we want to work on login. So login is what we bring. So we'll bring it into the sprint. So in this sprint, like now, your own test plan, your test control is in this backlog. You bring test control into the plan here. So now, so in this sprint, we put it, let's say login is what we have now. Your login. So in this login for sprint, where is being logged. So once we have it that is going in the sprint, it goes to development phase. The development phase? The developer start developing. So once they finish developing, they hand it over to the tester. So once they hand it over to the tester start testing. Happy, yes, we are fine. It goes to an integration phase. Integration phase is still we looking at it. Okay, we are ready. Please, who are we going to send it to? Now it goes back. So under this integration, then it goes to delivery. Let's give it to the customer now. The integration phase would have gone through all the test environment, all tested properly. We are happy with it. Then we deliver. Then once we deliver and the client they come back with feedback, we'll fix. They're happy. Yes, this login is working as expected. Thank you all. Then we are finished. That's for sprint is an iterative measure. So we have finished sprint 1. Sprint 1. Now sprint 2, we go back again. Ready. Everything is in backlog. We'll pick the second one, search functionality. We'll take it into the sprint. In this sprint, yes, that's what it goes through development phase. Happy. We finish development. We give it to the tester. Tester. I'm happy. Integration. Now we've integrated everything. Is linking. I can log in. I can do the search functionality. Now we've delivered it to the customer. Happy. He sends his feedback, and then we are ready. So we keep going through this loop until we kind of finish. So that's the way the incremental phase is. I come back again to say the same thing. So this is requirement. We build one. So these are the requirement. You design and develop, testing, implementation. So you design it, you develop, testing, implementation. It's just a phase of me iterating what I've been saying before. So it goes into the loop until you finish testing. So we keep testing. So in a nutshell, that ends software development lifecycle. Now, it takes us to this person. So what I want you to notice before I start STLC. So what I want you to understand is that the word software development lifecycle. Remember, when I was teaching software development life, I took everybody within the team, requirement gathering, which is done by BA product owner, the design phase, which is done by the solution architect, development phase, which is done by the developers, then testing, which is our own remit, then deployment, the developers. You see the release team, all those ones. So those, you see that we are all in one team. That is software development lifecycle. Now, software testing lifecycle is we as testers. This is where our own is now. So we are now talking to ourselves. That's where we are bringing ourselves. Requirement analysis. So look at it again. It's a life cycle again. So starting from this requirement analysis. So when we have gotten the requirements from them, we understand it. Then test planning. We start planning. That is what I've done. I did that test planning so that you can start writing your test plan. So after then, we start test design. Remember, if you look at this whole cycle again, that someone should just tell me, what does this cycle remind you of? You can just unmute yourself and say, there's a process we did in the background, first background. Who can remind me of this?
The chicken and the egg
That's the life cycle.
life cycle. Yes.
In the first background lecture, we always come back to these 5 principles. When we did it, the general testing principle, there's the other one. Who can remember?
Fundamental test process.
God bless you. Thank you. That is exactly what we are trying to preach here. You see that that fundament is you. It is you as a tester that you own this. So this software testing lifecycle, you see, requirement analysis. So this is mainly the beginning of it. Test planning and control. That is our phase 1. This is our phase 1. We are doing your test plan. That's where we are. Test plan and control. The phase 2 is test design and implementation. So while we are doing our test design, at the background in parallel, the environment is being set up for us. We have a test environment ready. The phase 3 of it is where it incorporates this environment and the test execution. That's where the phase 3 of it coming. Phase 2 of it phase 4 of it is when we say we are exiting it. Test closure report. That's where we are exiting. We are stopping. We are happy. We finished. That is it. So always remember, this is our own cycle as a tester. So STLC, the acronym, we have seen it. Software Testing Life Cycle is a sequence of different activities performed by the testing team. Now, I have now taken a niche that this is our own phase. The previous one was every one of us face software development lifecycle, but the software testing now is we testers face. To ensure the quality of the software or of the product. That is what STLC. What is the role of STLC? Even with the most talented, highly skilled team of developers, mistake can happen, even you and I. And the reason that we test in various environments is to ensure to minimize and reduce the mistakes that we're going to find. It's not, I said exhaustive testing is not possible. You cannot say that a particular application is bug-free. No. I handed over a phase today to the UAT team, though I'm still going to go there on Tuesday to help in that phase. But by and large, every phase there's still going to be an error that will come in. And that's the reason is that we that were in phase 1 in test environment, we've tested a lot. So you won't see the bugs again. If you go to UAT, it's going to behave differently because it's a different environment. Other people are looking at it. Phase 3, maybe you are going to pre-prod. Likewise, the same thing, and until we get there. So mistake can still happen as a result of human nature. The role of software testing lifecycle is to identify any mistakes that have been made and find solution for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. That's the most important thing. What are the phases? The software testing lifecycle consists of 6 main phases. It's 6, each of which includes specific action designed to ensure that high standard of performance and quality is achieved. These are the 6 phases. Number 1, requirement gathering analysis, test planning, test case development, environment setup, test execution, test cycle closure. So we'll start taking each of them one after the activities in requirement analysis. 1, identify the types of tests to be performed and assigned to the development. That's what you are trying to do. You identify the test that needs to be performed and you assign it to them. Gather details about testing priorities and focus. Prioritize, you remember. Prepare requirement traceability matrix. I always tell you, whatever I'm telling you, I've done it. I do it. I'm still doing it. So that's why I always tell you, when I'm talking about this, I say it with passion. This is a job that I love to do. I'm happy with it. People even tell me I overstress myself even at work. It's not stress for me. It's just something that I enjoy. I've taken it as part of a life because this is where I found myself after some time, and I think I love it. Identify test environment details where testing is supposed to be carried out. Conduct automation visibility analysis if needed. So you'll understand that. So those are the phases. Deliverables of requirement analysis. RTM, requirement traceability matrix. This document marks and trace requirements proposed by the clients with test cases. Let's take it as a layman example. You've got user story 1. I'm using this because it's just like I'm telling you what I'm doing today at work. That is what I'm just trying to say, that this is the way. So user story 1. If I'm going to hand over to UAT, I take user story 1. All the user story 1, you might have like almost 20 to 30 things that needs to be. In fact, let's say most things is like maybe 100 things that needs to be achieved in that user story 1. I take the requirement one after the other. I have a worksheet that is requirement traceability. I now take it. Then I tell all the people under me working with me, though I do most of this job myself, I test and I do them myself. I also get my hands very dirty. I can tell you most of the application, I'll still be the SME for it. So when I tell them, if you test this, my test case, map it to each of it so that I have a visibility that I've got good coverage for it. That is what we call test coverage. So when you map it to it, it makes you understand that I have tested this particular user story correctly. So in that user story, they might ask you that login should have 8 this thing. Write the all test cases that your edge cases, both positive and negative scenario, to attach to it. That's it. You can put it in a workbook. It gives you visibility of what you're doing. Attach it to it, trace it to it. So you will know that you have covered X number in this. You have a good coverage. When people come to you that this failed, why did it fail? We have tested it and I'm sure. And you bring it there as an associated set of test cases against it, just to ensure. Automation visibility reports, if applicable. So I also do automation test strategy, just to, if it's within my remit. I do it. This report would be produced as a result of analyzing the project, working out what screens have components that can have automation tests written against them, the complexity of writing the automation test, whether the test case handle large amounts of test data, among other factors. So those are the checks that you need. Test planning. The test planning, we have talked about it in previous project, and that's what we did in our last class. I'm not going to emphasize more how to write a test plan, test strategies. That's what it's all about. Test planning phase is usually conducted by the QA. I don't say a QA manager. It's usually conducted by the QA, by the QAs. It involves creating the test plan and test strategy documents, along with determining the effort and the cost estimate for the entire project. We've done this in the last class. Activities of test planning. Preparation of the test plan and the test strategy document. You see that everything is just repeated now. Selecting any tools required during any testing phase, test effort estimation, training requirements. That's the same thing we have said. So that's it all about test planning. Deliverables of test planning document. By the end of this period, if you've not written your ISTQB, we need to adhere to it. We have rules and regulations that governs testing generally. So this defines a test plan is a document describing the scope, approach, resource, and schedules of intended testing activities. Test effort estimation document. These documents will include estimations of how long it will take to complete the testing tasks. So that's the deliverables. Test case development. I think Pat taught you about test cases. So it's just now you are talking about the repeated phases because we have already done those phases. So it's now for you to, it's just a refresher of what you have done before. The test case development phase includes the creation of test cases for each unit and any test scripts once the test plan is ready. These test cases cover validation, functionalities, and points of verification described in the test plan. That's it. Activities in test case design. I love this topic. Preparing the test case and any automation script if required, enumerating the possible actions of the users and the objectives, setting the priorities of the test conditions, selecting the conditions under which test will take place, documenting any test conditions, verifying and correcting the test cases based on modification. So those are the activities of test case design. What are the deliverables of test case development? Test cases. This is a set of actions that test a particular piece of functionality of the software project. Test data, input data. What are test data? You for your login functionality, it says use email and password. What are your test data here? Email. What is your email? yemi@test.com. That's a test data. What is password? 12345. That's it. Another one, test@test.com. Take it. What is the password? 54321. That's it. So those are test data, your input, what you add when you are meant to register, your name, your this, your ID, your phone number, all those are test data. Test automation script. This is a script created by automation engineers with the idea of them being run frequently to reduce the reliance of manual testing. To be honest, we can't still do 100% automation. There'll still be a validation phase, someone to be checking X, Y, Z. So the next phase is the test environment setup. The test environment consists of elements that support test execution, the setups of testing environment is done based on the hardware and software requirement list. The test environment should mimic the production environment as closely as possible to uncover any environmental or configuration related issues. This phase can be in parallel with test case development phase. So they've told you what the specification is. Whosoever is developing test environment, always mimic what is in the production, what's in production, but they just make it lower because these things, all this environment I'm talking about, they also have cost implication with it. So you want to ensure you are hosting an environment in the cloud. It costs thousands of money to be able to do that. So those are things like that the organization look at. So activities, analyzing the requirements of preparing the list of required hardware and software to set up the environment, setting up the test environment, executing a smoke test on the test environment to validate the readiness and stability of the test environment. So these are activities to be done when you're setting up. What is the deliverables of setting up test environment? The test environment is ready for the test execution phase, smoke tests, results. So before a test environment, it's wise to do smoke test. Once they give you an environment, don't just say testing has started. Always insist of a smoke test. Pull a policy through. Sorry, I'm using policy because, walk through a process. Policy because it's not that I'm talking about a policy, but because of the current project I'm working on might end up making me use the word policy. Policy is just I'm working on thing. That's where I work, and that's what we do. But let me say, ensure you have access to the environment by logging in, doing a search, pull things in the basket, just a smoke test to see that the environment is working as expected. Test execution. The test execution phase is the execution of test cases that have been created as a result of the test case development phase. This is done by the testing team, where bugs are reported back to the development team for them to fix, with retesting to perform at another time, depending on the software development model and the project is following. So this word, retesting. So I'm going to take another two words. Please write them down. Retesting and regression. Retesting and regression. Retesting. When a bug is found, for example, if you try to log in and you can't log in, it's giving you an error or the page crashes. That is a bug. You raise a bug, the developer picks up the bug and fix it. That is a bug. When that bug is fixed and you are told to retest, you go back, you try to log in. Now, you are retesting that bug and you've been able to log in. Now, when you finish retesting, you also need to do regression. What is regression? Before you have the old BlueSky environment ready, you were able to log in. You've already tested the search functionality. You've already known how to add to a cart. You have finished all that phase. But because you were not able to log in, they have fixed the login. Now you can log in. When you log in, you need to do a regression to ensure that that search functionality, due to the fix that was delivered, did not break the search functionality, did not break what was developed before. So that is when regression is. So the first thing that takes place is retesting. You retest that bug. When you retest it, you now want to do a regression to ensure that whatever was retested, whatever was deployed, did not break what you have in there. So those are another two guys to be. What are the activities? Execution of test cases, recording results of the company's in the company's test case management tool. We talked about this in the last class on Wednesday. Reporting any defects for any failed test cases, retesting any defects after these have been fixed by the development team. What are the deliverables of the test execution? 1. Reporting on any defects that have been raised during the test execution phase. 2. Overall overall summary of the test case results. That's what are the major things that you do. Test cycle closure. The test cycle closure phase involves the analysis and evaluation of the whole testing cycle to work out what worked and what didn't work. The QA team needs to meet to evaluate the cycle completion criteria based on the test coverage, quality, time, cost, software, and business objectives. The bug and test cases reports are analyzed to identify the distribution of defects based on severity and type. After test completion of the test cycle, the test metrics and test closure reports will be created. So all these are mainly repeating what we have said in the last class on Wednesday. This is just test closure. We have finished testing. We have stopped testing. We've completed our test. These are just documentation to say you create a test completion report to close it. You give all your test metrics, what has been executed there. What are the activities? Preparation of test case closure report. Evaluate the cycle completion criteria based on the test coverage, quality, time, cost, software, and business objectives. These are what you base your yardstick on. A good coverage. I've told you, that's why we have the RTM, requirement traceability matrix. Prepare test matrix based on the above parameters, what they have said above. Deliverables of test cycle, test metrics, which is vital. How many test cases did you execute? What passed, blocked? That kind of report. Test closure reports, I've just said, a document that gives a summary of all the tests conducted during the software development lifecycle. It also gives a detailed analysis of the bugs removed and errors found. So that's it. So we are getting to the end of it. Interesting part, defect life cycle. What is defect life cycle? The defect life cycle describes the different states a bug can be in through its entire life. It can also be referred to as bug life cycle. Defect, bug, fault, they are all same thing. The defect life cycle also involves the classification of different priorities and severities of bugs identified by the testing team. Defect priorities refers to the order in which defects should be resolved. Take these two words again. Priority, severity. Priority, severity. These words that they are key words. Most people mix them. And I tell you, most test managers ask all these questions, most of them. So we know from there, once you give me this, that, I will know that you know it or not. So defect priority refers to the order in which the defects should be resolved. For example, if you can't log in into an application, you can't use the application, you can't use the website. So you know that the first defect to be fixed should be that login phase. That's the priority. That's the first defect to be resolved. So that's what we call priority. While the severity, it classifies the impact, how it affects you, how it affects that application. So if you cannot log in into the application, you can't use it. So what it means is that it has an adverse part to do. Is severity is critical. In fact, you can even call it a major one because you can't access the application. It's just like have a bank app. Nobody can use the bank app for the next 1 hour. You would have seen the whole country will be calling the provider to say, I can access it, I can access it. By that time, you have lost a lot of others that will be switching. I want to move my money. I can't wait. So those kind of thing is high demand. Within 2 seconds, I'm telling you, thousands of developers all over the world working on that will fix that thing and put it live immediately. So the severity classifies the impact of the defect and the complexity of how the fix is. So in priority, always have it in your mind. The way priority is that it tells you high, medium, low. Yeah. Severity, major, critical, medium, low risk. So those ones too. But you have critical, major, high, all those ones are things that come under severity. So this is defect life cycle. So the first thing is that I found the defect. I couldn't log in. I'll raise it. That's the first thing. It's when you raise the defect, there's a process. Okay, we look at it. I've put the defect on ADO. Is it rejected? Someone will have a look at it. She can't log in. You can't reject that kind of defect. So you bring it. It's open. So now it's open. Are we going to fix it now? Because it's a login defect, definitely it has to be fixed because people can't use the application. So then hence we can't defer it. So we come here, it's opened, we fix it. Once it's fixed, you retest it. When you're happy, you close it. That's one route, happy part. You see, just new defect, it goes to open, then the developers fix it, we retest it, it's fine, then we close it. That's a loop. But if you raise a defect and they say, oh, maybe it's a cosmetic, okay, no, they reject it. Or if they feel it's not a defect, it might be rejected. Agreed. So we can't do anything. So you close that defect. It's rejected. Having said that, that's another phase. Also, you can raise a defect. Then they look at it. Okay, yes, it's a likely defect. It's opened. Now, we look at it in rating. We triage it. We call it defect triage, where you discuss it. How do we want to resolve it? Is this one going to take time? If they feel that it's going to take time and it's not needed in this phase, they can actually move it and defy it and say, okay, we will fix it in the next phase. We'll start working on it once this one is deferred. That's another phase is deferred. Then another loop is that you create a new defect, you open, is fixed. Is opened, is fixed. You retest. So when you retested it, you found that it's not still working as expected. You go back, you reopen that bug. Then when you reopen it, it goes through the loop again. You fix it, it comes back to retest. You go through that cycle until when you're happy, that's when you can close it. So that's the way this cycle works. Finally, defect life cycle. So the first state, the new, sorry, excuse me. The defect has been raised, but haven't been validated yet. That's in the new status. Assigned, like open. A member of the development team have been assigned the defect. Active. The defect is now being investigated by the development team. These are states that you should notice. Test. The defect has been fixed and is now ready for QA team to verify. Then reopened. The proposed fix has been rejected by the QA team, so the issue remains unresolved. Verified. The defect has been fixed and verified by the QA. Closed. If the defect is no longer exists, the state of the bug is fixed and is set to close. These are various states of software, of defect life cycle. Rejected. If the defect has already been raised, reproducible or not a defect, then bug can be entered or in a rejected state. Deferred. This is when the bug have been prioritized for the next release. So those are just the phases. The states. Defect priority. QA typically sets priority status when the defect is brought to the attention of the development team and is based on the user's requirements. Low priority. The defect fix is not an urgent nature and can be delayed until more important fixes are completed. Medium priority. The development team should fix the bug if bug in subsequent builds. High priority. The impact of the bug on the software is substantial and should be addressed immediately. Urgent priority. The product cannot be used until the defect is fixed, so it should be resolved urgently. So these are defect priorities. Defect severity is based on how severely the defect impacts the functionality of the software and how complex it is for the development team to resolve. One is the critical severity. The defect affects the core functionality of the software, and the QA team cannot continue testing the product until it is fixed. An example is the one I gave you of the login, so that you can't continue testing. So hence is a blocker. An example of a defect that is critical of a critical severity is one that causes the product to crash often. So it's an example. Major severity. The defect affects core functionalities considerably, but the test team can continue testing other aspects of the software without the one first having to be fixed. So an example would be, you can still log in. So when you logged in, maybe the issue that you got was that the search functionality got broken and you searched it, but that's the one you have raised. You can still log in, you can go to the navigation, you can look through, you can check your previous payments. You can still do some things it doesn't stop you from testing. That's what that is saying about medium severity. This defect impacts just one screen or one specific functions, but does not actually stop the function from working. Low severity. The defect has no impact on the product's functionality and is likely to be pure cosmetic, just cosmetic bugs. For example, maybe the login page, you wanted it to be sky blue, but it's blue, but it's not that sky. Those are cosmetic bugs, can be fixed at any time. Fix are likely to improve the UI UX. So the difference between them, software development life cycle is what we call SDLC. This is development life cycle. STLC is test life cycle. The main objective of software development life cycle is to complete successful development of the software, including testing and other phases. But STLC, the only objective is the STLC phase. Is testing. It's just testing. So in SDLC, the business analyst gather requirements and creates development plan. In SDLC, the QA team analyze requirement documents like functionals and non-functional documents and create system test plan. In SDLC, the development team creates the high and low level design plan. In SDLC, the test analyst creates the integration test plan. The real code is deployed. The actual work take place as part of the design documents. The testing team prepares the test environment and executes them. SDLC phase also includes post-deployment supports and updates. Testers execute regression suites, usually automation scripts to check maintenance code deployed. So these are just various differences of them both. So I just put this for you to see. This is SDLC, requirement analysis. So we do the system testing against it. So this is STLC, high level. We do the integration testing, low level design, unit testing, then the code. So finally, test level. If you remember, we've done all this validation phase, unit testing, integration testing, system testing, acceptance testing. Remember when we did the V module, when I explained to you the validation phase. This is the validation phase, and that's what's called the test levels. So types of tests, that's test types. We've got non-functional testing, performance testing, which load, stress, and volume testing. So you want to know how many capacity can use that application at once. So all these are part of the things that you put in as load testing. Security testing, usability, compliance testing, sanity testing, structural testing. So the other thing to look at is smoke testing and sanity testing. What is smoke testing? Just checking that the build, the deployment, things are still, you've been able to assess the environment. Why sanity test is that you can do when the build, when is the deployment is completed, you can do the major things that you were doing before. So take smoke test like you are like the way retesting and regression is. But smoke test is you testing whether the application you have access to it is that. But sanity test does a thorough one by going for that to look that that build is being deployed properly, ensure that we have the right things in there. So types of testing continued. We've got the functional testing, which is the review, smoke testing, retesting, regression. So testing. So testing verifies and validates that software or application is bug-free. Testing identifies defects or bug. Testing helps to identify failures of software. What is debugging? Debugging is just like you checking, why is this thing failing? You are trying to look at the root cause. Is a process of fixing a bug, defect in a software. Debugging removes error. Debugging identifies, analyzes, and removes bugs. Types of testing, we've got static testing, dynamic testing. Static testing, no code is involved. No, is a verification state. The code is being examined without it being executed. Dynamic, static is stay there. Don't do anything. Just look at me. Dynamic is moving, moving, moving according. Done at validation phase. Code is being executed and tested without necessarily being examined. So review the test process. A review is a systematic examination of a document by one or more people with the aim of finding and removing error. Given a draft document to a colleague to read in the simplest example of review, and one which can usually yield a large crop of error than we would have anticipated. So these are types of review: informal review, walkthrough, technical review, and inspection. So walkthrough, most of the time, what walkthrough means is that train me, explain to me how this thing works. So if you get to an organization today, you ask them, you don't use the word come and teach me. You tell them, can you walk me through the application? Walking through. So when someone is walking you through the application, can you train me to be able to use the application? But we don't like to use that word. I told you, use professional so that people will think she under. So when you get there, do you have any documentation? Can you walk me through the application we are working on? Can you? So they'll tell you everything. So those are the ways that it is. So I believe test script has been done in the last class, and this is how we are going to end our class for today. And I'll stop sharing. Let me now go to the chat so you can